All right, guys, we are going to talk about hydroelectricity or hydropower or water power, however you want to think about it. And this is section 6.9. So you need to be able to not only describe the use of the use of hydroelectricity in or with respect to power generation, but you also need to be able to look at the impacts of hydroelectricity on the environment. And so, as a part of hydroelectricity, you'll also need to not only look at traditional damming of rivers and generating electricity that way, but also looking at tidal power as well. So, some basics about hydroelectricity. So we're taking the kinetic energy of the moving water, so water that is flowing typically through a stream, and we're going to use that to spin a turbine to generate, which is generating mechanical energy, which is then going to power a generator, which is going to create that electrical energy. So much of the same process that we've been talking about with fossil fuels or with nuclear energy, except that we're not heating the water. We're simply using the kinetic energy of the water to spin the turbine. So we can look at it with the natural current of the river, or we can do it with tides, or we can dam a river and then kind of have the water drop and use that kinetic energy of the falling water. So, if we look at renewable energy globally, hydropower is the number one renewable energy source worldwide. So, if you look at this graph here, we can see that the majority of renewable energy comes from hydropower, with wind coming in second, and then solar, and then some of our other renewables after that. So when we think about countries around the world that have invested in hydropower and are generating a large amount of energy through hydropower, China, Brazil, and the United States are the three biggest hydroelectricity producers globally. So I really need you to understand this process in terms of how does it work? How are we getting energy from water? And so typically we are going to dam a river. So we're going to build a dam in a river. We're going to create an artificial lake behind that river. Behind that dam. So we're going to dam the river and then create this reservoir or this big, basically storage tank of water behind the dam. And then, so what that allows us to do is to control the flow of water so that we can increase the amount of water going through the dam, or we can decrease the amount of water depending on our electrical generation needs, essentially. So if we look here, we've got this dam and then this reservoir behind it. And then here is where we're going to get the water, or what we call the intake, is going to flow through here. It's going to spin this turbine, which is then going to run a generator and create electricity. So a dam allows us to control the amount of electricity that we're producing, but it also helps in terms of prevention of seasonal flooding. So a lot of times a dam is a welcome thing because it's going to prevent the flooding downstream that may be experienced in the spring or during large rainfall events. Another positive about the damming of rivers is it creates this large reservoir behind the dam. And so that can be a source of revenue because now we have a place to boat and to fish, and you can build homes along the edge of the reservoir. And so it increases property values, which in turn increases your tax revenue and things of that nature. The two big environmental impacts that you would look at in a negative light are, one, when you build the dam, you're going to flood the land behind the dam. And so you are going to ruin or flood ecosystems that were previously intact behind there. And then the other thing that happens is that because we're damming the flow of the river brings with it sediments, and those sediments are often rich in nutrients, and so those nutrients don't continue downstream, and they can build up, those sediments can build up behind the dam, and we call that sedimentation. So that may need to be dredged periodically to remove the sediments that are building up behind the dam. So what happens is, if sedimentation is happening, it can decrease the energy output of the dam, which is why sometimes that needs to be dredged and removed. So another system of generating hydropower is called a run-of-river system. And then we also have tidal power. So now these are different than our traditional hydroelectric power plants where we're damming a river. A run-of-river system, you're still going to dam the river, but you're going to divert the natural current, and you're going to kind of send it through a channel, and then that's where that turbine is going to generate. It's going to spin and then generate electricity. So this run-of-river system is more environmentally friendly in that it's not creating a reservoir behind a dam. So we're not losing those ecosystems behind a dam. It is still damming the river, so it does make it so that if the river is dammed, then navigation can be an issue and that kind of stuff. But we're not creating that reservoir. So we're just creating this channel here where you're going to run the water through this channel and then into an area where we're going to spin turbines and generators, and then we're going to put the water right back into the river where it was. So because we are not creating this massive dam with a massive reservoir behind it, there is still natural flow of sediments through that dam. And so we have less sedimentation as a result. The issue is with this kind of system is that it doesn't generate nearly the amount of power that a traditional hydroelectric dam might create. And if water levels get too low in the summer, it may mean that at some point you can't even divert the water through this system because the water levels are too low. Another type of hydropower is tidal power. So this comes from in coastal areas where the tides go in and out. We're getting those tides to flow through a system of turbines on their way in and then again on their way out. So as the tide changes, we have movement in, spin those turbines, or movement out, spin the turbines again. One of the things about tidal power is that you really have to have a very large differential in your tides. So the area, Delaware, we don't have a large enough difference between high and low tide to really make this type of power worthwhile. It's very, very expensive. And the other thing is it needs to be done in an area where kind of it's going into a narrow bay and then coming back out of this narrow bay so that you can get the largest amount of power possible. There are not a lot of these tidal generating stations worldwide. There's one in France and a couple others in Europe, but not many. So, drawbacks of hydroelectric dams. So, in green are the ecological issues. So, the reservoir is going to flood habitat behind the dam. So, we could lose forest habitat, we could lose wetland habitat. And we know that wetlands are super important in terms of water filtration and breeding grounds and things like that. Um, it also prevents upstream migration of fish. So salmon, particularly, are born in freshwater rivers and streams, and then they swim out into larger bodies of water, big lakes and oceans, and then they return to spawn or to mate and to lay their eggs back in the original place that they were born. If a dam is there, it creates a problem for those salmon not being able to return to their original spawning grounds. Sedimentation is another ecological problem that we talked about. So sediment builds up behind the dam. This often creates it so that the upstream habitat becomes warmer. There's less oxygen in those upstream habitats, and then the rocky stream bed that a lot of organisms need to lay their eggs becomes covered in sediment. So it's no longer ideal for laying eggs. Downstream, we don't have those sediments coming downstream, and so we are losing important nutrients that were in those sediments. So again, we're having some issues with habitat. Downstream wetlands also really suffer because these nutrients don't reach them, and so wetlands are very, very productive, but if there aren't enough nutrients in the wetlands, they can't be as productive as they might have been. Another environmental issue or impact is that fossil fuel combustion, when we build the dam, we're gonna use fossil fuels. And now also because we've created this large body of water, we're going to have increased evaporation. And in these bodies of water, especially because the upstream body of water can become oxygen poor, we can start to have anaerobic decomposition, which releases methane into the atmosphere, which is a greenhouse gas. Some economic impacts of these dams. Obviously, if there were previously existing homes, businesses, towns, things like this behind the dam, those get flooded and they would need to be relocated. Initially, the cost of building dams is very, very high. The cost to run them is low, but the initial construction of the dam is high. And so there's jobs initially, but there's not long-term jobs. And then we have to dredge for the sediments, which comes at a cost. Also downstream, because of the lack of nutrients and reduced water levels downstream, we may see the dry up of wetlands downstream, which can be problematic. Now, the last thing in there was also potential loss of fishing revenue if salmon breeding is disrupted. So this is an issue. Salmon are a big business, multi-million dollar business. And so what has happened in a lot of these cases is that we've built fish ladders to deal with this issue of the salmon not being able to get beyond the dam. So a fish ladder is literally, it's like a series of steps or concrete little platforms that the fish can jump their way up the dam. So here's another example. So they can get into here, jump up, jump up, jump up, and then they can get to where they're trying to go. So this allows for the salmon to still breed. The salmon are not only an important revenue, but they're also an important food source for eagles, osprey, bears, things like that. The other thing that sometimes happens is during this breeding season, we can have a salmon cannon, which is literally like it sounds. You can see it in the picture there where they are putting the salmon into this chute and basically shooting them up and over the dam. The salmon go up to spawn to lay their eggs and then they die. So this is not harming the salmon, but it is getting them to where they're trying to go. The benefits, on the other hand, of hydropower, there's no greenhouse gases when we're producing the electricity. So running of a hydroelectric power plant does not create any greenhouse gases. We talked about that the reservoir behind the dam can be an attraction and tourist revenue. There are jobs created to maintain the dam. It is a reliable source of energy. So we're not really weather dependent. We're somewhat weather dependent and snowmelt dependent, but traditionally it's very reliable as compared to some of the other renewable energy sources. There's no air pollutants, so no particulate matter, no sulfur dioxide, no nitrogen oxides. And then it allows for the control of that flooding downstream, so it can be helpful to downstream communities. So in the US, we have lots of dams on many of our rivers, but only 3% of dams are for hydroelectricity. The majority of our dams are for recreation or scenic purposes or for flood control. So these hydroelectric dams can provide both of those things while still providing power. We talked about that the flood prevention is really good for people, but that it means that the nutrients are stuck upstream, and then that can be problematic for the wetlands and things downstream. And so what I'd like you to do is explain two benefits other than agriculture and recreation that people could gain from constructing dams and rivers.